Hello, I'm the Cheshire Human, not to be confused with my cat counterpart. Today I'm going to talk to you about the Frankenstein of Mathematics, piecewise functions. Just a short little disclaimer before we get in. This is my first time creating something like this, but if you're interested enough into the topic, you will be able to grasp the concepts if you watch into the video. So I tripped over my word a little when I was recording this, but that's okay. You'll still be able to understand about the Frankenstein of Mathematics. Enjoy. Piecewise functions are essentially multiple functions mashed together to create one big Frankenstein function. Each subfunction in the piecewise function is true for set values of x. Here, let me explain by showing you a graph and its function notation. So here on the graph we see many lines starting and stopping seemingly at random, but if we look at the function notation, a little light is shed on this mystery. In the notation we see three separate functions, and then next to them, the values of x where that function exists. We can see that for all values of x less than 0, the function f of x equals x squared is to be graphed. This means that after 0, the function f of x equals x squared is no longer to be graphed. Instead, you're supposed to graph f of x equals negative 3 up until when x is greater than 3, in which case the function of f of x equals negative x plus 3 is to be used. When you combine all of these things together, you can get an amazing looking graph that is stitched together from random parts of functions that looks like a Frankenstein. Now real quick, I would like to cover a classic mistake that people might make when trying to make a piecewise function, whether if they're trying to create a practice problem for themselves or maybe for their students, and that is the piecewise function still has to pass the vertical line test, else it will not be a function. Yes, these functions still have to pass the classic vertical line test. This is a classic mistake to make a function that does not pass the vertical line test and therefore is not a function. Now let us return to our previous graph and its function notation to cover some problems you may encounter when studying piecewise functions. Arguably, the most common types of problems you will come across when dealing with piecewise functions is a problem asking you to find f of something. Now let us delve into some of these problems. For example, the first one says, find f of 2. Now we go back to the function notation and look at it. And now we look. Is 2 less than 0? No, it's not. Is 2 greater than 3? No, it's not. Is 2 greater than or equal to 0 and less than or equal to 3? Yes, it is. So for f of 2, we would graph f of x equals negative 3, which gives us the answer of negative 3. On to the next problem. Find f of 3. Again, we go back and check. In this case, 3 is less than or equal to 3 and greater than or equal to 0. So we graph this the same as we graphed f of 2, so the answer is negative 3. And finally, find f of negative 1. Negative 1 is less than 0, so we would insert negative 1 into the equation f of x equals x squared. If we compute that, then we get f of negative 1 equals 1, and there's our answer. Thanks for watching this far into the video, and you have reached the end. So, if you would like more of this content, then leave a like, and also check out my channel, because more of this will be coming soon. Again, thank you so much for watching, especially since it's kind of my first time, so I tripped over my words a little, but I hope you liked it, and I'll see you down the rabbit hole. Happy Halloween!